Conformal compares all the compare points in your design, which are the primary outputs, the cut gates, the black boxes, the flops, and the latches. Conformal breaks down your design at such compare points and compares the two designs by the logic cones at each of these compare points. In the case of a flop, let's say it has 4 input logic cones like the D cone, the clock cone, the set and reset cones. Then each of those logic cones must successfully compare in order for that flop to be considered as compared and equivalent. For the black box, each input pin is a logic cone. In order for the golden and revised black box pair to be equivalent, all the corresponding input pins must be equivalent. If each of the compare points and key points are successfully paired during mapping, then we can compare each of these logic cones. The two designs are considered equivalent when all the corresponding logic cones are equivalent. The compare points are the endpoints of your logic cones. We compare the two designs at these compare points. In this example, we have a primary output as a compare point. The tool provides input vectors to the logic cone starting at the output of the flop and also the outputs of the black box. We can give 0 or 1 at any of these start points and then determine whether the output at PO is 0 or 1 on the golden side. Then, we do the same on the revised side. If the results at PO on both golden and revised match, then these compare points are considered equivalent. The tool tries to provide the minimum necessary and sufficient vectors at each compare point to prove that the two compare points are not equivalent. All the primary outputs, cut gates, the black boxes, and the flops are considered compare points. Regardless of how many inputs the flop has, the entire flop is considered as one compare point. Thus, if any of the inputs of that flop fail, then the entire flop has failed. Conformal will report that failed flop as one non-equivalent compare points. Similarly for the black boxes, if any of the inputs of the black box fail, Conformal will report the entire black box as one non-equivalent compare point. You can later diagnose each of the failed, non-equivalent compare points to determine the root cause of the problem. In Conformal, we assume that there is no connection between the inputs and the outputs of a flop, a latch, a black box, or a cut point. Think of the flop or the latch being cut in half. All the logic cones that end at the inputs of your flop are verified separately from the logic cones that begin at the outputs of the flop. In other words, the logic cones end at the inputs of these flops, and then a new logic cone starts at the output of the flop. So, we are breaking down the design at the flops and at other key points so that the verification is simplified. Thus, we can assume that the outputs of this flop behave independently from the inputs. For example, if you have a constant 0 input that's driving D, logically, that would make the output at QA constant 0. But, for the purposes of equivalence checking, you will assume the Q output to still have a value of 1 or 0, independent of the constant 0 input. The same holds true for latches, cut points, and black box inputs and outputs.